So as you're getting started with this and you're getting through these first couple problems, I do see pictures being drawn, which is very good. Draw a picture, show your critical value, z-score formula. I was asked, can we use that one website? Yes. If you do not have it bookmarked, you could probably find it with an easy Google search with the guy's last name, which is Bogner, B-O-G-N-A-R, and the second word applets, A-P-P-L-E-T-S. It'll give you that full list of them. And then on the left-hand side, you go down to normal, and it'll help you figure out some of those calculations that you can do as you're working through this. So like I said, as you're thinking through explanation, go ahead and answer for me. Why is the mean the same as the median? And I will randomly select. All right. So because it's a symmetric graph. Answer to number 2, what is the z-score for a patient who takes 10 days to recover? What is the answer to number 2? A long number. 2.2238. Did you use the z-score formula? Did you show the z-score formula? You have to make sure you do both. 2.23. Yep. Z equals x minus mu over sigma. Always show it. Then put the numbers into it. Then show the answer. Interpretation of the z-score. What does the z-score tell us? It tells us relative positioning, which isn't a correct interpretation fully. But this means that 10 days is 2.238 days above average. So if you didn't get a good explanation down, something along those lines, that the 2.238 was the number, that a 10-day stay is 2.238 days, 2.238 standard deviations above normal. Not days, but standard deviations above normal. Above normal, above average, above the mean, something like that. All right. Did you finish 3 and 4? Quick show of hands. Just raise your hands because I can't see all the boards really well. Did you finish 3 and 4? All right, we have hands that are sort of up. What I want you to do is take a couple minutes, go around. If you got 3 and 4 done, go around and check the other boards, see if yours compares in terms of did you show all the work. When I say show all the work, I drew a picture. I have my values recorded on it. I have it correctly shaded. I have shown the formulas and entered values into the formulas, and then I have a good probability statement with an answer. And then the last thing is an interpretation statement, which basically goes back and repeats the stem of the question with your solution in it.
So you want us to explain the answer?
Yes, explain the answer. So it ends up being like a paragraph, right? Introductory is the given information, information point, information point, information point, and your conclusion repeats your starting point. All right, so we did this already. And we said that the z-score for the patient is using the z-score formula. I think we said it was 2.28. I can't remember off the top of my head. But the point here is showing that you can take the information. So the point of a question like this is you can take this information and know, it's a normal curve. The average and the standard deviation. I didn't draw a picture here, but it's never a bad idea to draw a picture. X. This is 5.3 in the middle. 1, 2, 3 standard deviations up. 1, 2, 3 standard deviations down. And we're going up to somewhere right around here, and that's where 10 is. And showing that a person who is in the hospital for 10 days is 2.238 2.238 is 2.238 standard deviations above the average. You did this. The probability that a patient selected at random takes more than 4 days. There's my probability statement. Draw a picture. X, 5.3, 1, 2, 3 markings, 1, 2, 3 markings. Not a bad idea to throw one of them else on there. So 5.3 minus 2.1 is 3.2. So I can see the scaling. 4 is somewhere here. I'll label it as 4. And then I'm going to shade all the way above because that is what I'm looking for. More than 4. Use my z-score formula, x minus mu over sigma. 4 minus 5 over 2.1. 5.3. What was that z-score? Negative 0.619. Now, if you're using one of the tables, it all depends on what table you're using. In our textbook, the table it tells you that the table gives you the area from 0 to x. So what that means is in this picture, 0 is the middle, that's my mean. X is the 4. The table gives me this area. And that was like 0.2209, something like that. This area, because it's to the right of the 5.3, 5.3 is the mean, 5.3 is also the median. The median is the 50th percentile. That means half of the data is above, half is below. This is 0.5. Or you went to an online calculator of some kind and you did the normal applet, and then you plugged in the value for the mean, the standard deviation, the boundary point, you checked the correct shading region, and we found that the probability of here is 0.7. If you used the online, it was like 0.732 something. If you use the table, the probability that x is greater than 4 was about 0.72209. Something like that. And so you're going to have some variability in your answers depending on which source you used. All right? Since it's true that both of these could be considered right, what makes for a correct solution is picture, boundary point, labels on my graph that it's x. I've shown my z-score to find my corresponding z number. Even though I know the online applet doesn't require a z-score, I do. Because this then shows me how you're setting it up. What are you doing? And then if you go and you plug the wrong thing into a calculator or the wrong thing into the computer, I know that what you're doing is you're misusing the technology, even though you may have a proper understanding of how to set up the problem. But if all I have is this, and I don't have any corresponding work, I don't know where that number came from. And you say, but if it's right, then you'll know I did it right. I'm like, but I'm not going to just go with the hope that you maybe did it right or have really good eyesight and can take it off of the person's paper sitting in front of you or next to you. I need this. And then the final thing is, in words, there is approximately a 72.2%, or up here, 73.2% chance that a patient selected at random will spend more than 4 days in recovery. Procedurally, what about 8 days? Not much changes, except I have a new picture. Can I put it on the same picture? I would prefer that you don't. 5.3, 8 is up there. I'm finding this area. Z equals 8 minus 5.3 over 2.1. You're going to find that z-score. You'll find that corresponding area. You'll write the probability that a person staying in this hospital selected at random spends over 8 days is approximately something percent. Whatever that number is that you find using those online applets, your graphing calculator, or the table from your book. Without using a z-table or technology, what time represents the 16th percentile? Well, the minute I see that, I'm just thinking I got to draw a normal curve. 5.3, 1, 2, 3. This is 3.2, this is 1.1. That's going to be negative something. 1, 2, 3, add 2.1, 7.4, 9.5, 11.6. The 16th percentile means 16% of the data is at or below a certain value. So it's going to be somewhere over here. So if I'm not doing the z-table and I'm not using technology, I'm trying to remember what else do I know about a normal curve. And I saw many of you graph this from the get-go. How much data, now granted my graph is not super symmetric, it's kind of got like a dinosaur swoop to it there. We remember that, okay, I am from the mean, up or down 1 standard deviation is 68% is right there. 68% of the data is within 1 standard deviation of the mean. And that means these together are 32%. Because if it's not 68, what's left is 32. And because, and I'm giving this explanation out loud, but you'd be writing these things, and then because the normal curve is symmetric, I would know that this is 16%, again, because of symmetry. Got 32 gets split in half, so that's 16%. So the time that represents the 16th percentile is 3.2 days. Because this area is 16%. Using the empirical rule. And then what time represents the 75th percentile? So then we're going to do this. Draw a picture, 5.3. Right here is my number x. This is 0.75. If you're going to use a table, we're going to be looking for one of the many different tables that's going to get you. And inside of the table, if you remember the table, tables like this, it has something like, 0.0, 0.01, down to certain numbers across the top. This is 10, 11, 20, 30, 40. Across is 0.01, 0.02, 0.03, etc. What you're looking in there for will depend on what table you have. There are some tables that give you this whole area. If that's the case, I'm looking for the number closest to 0.75 inside the table. And then from that, it'll tell me what the corresponding z-score would be. I might be looking at a table that only has the tail areas. In that case, I'm looking for the number somewhere in the table that's 0.25. And then I'm looking for its corresponding row and column for that z-score. If you're going to use an online tool, here's what you need to do. For some of you are like, but I'm just going to use the computer. Here's what you have to do. On the online tool, for the mean, you need to put 0. For the standard deviation, you need to put 1. And in the red box for the area, you're going to put 0.75, and we're going to have x will be less than 0.75. So if you have that online tool available, why don't you open that up now? If you don't, let's try to find it so we can get access to that. So again, using those applets, We use the normal.html applet in the mean, and usually when you open it up, it's defaulted to that already. What that's defaulted to is that is the standard normal curve. That is the z table. So I put in 0 for the mean, 1 for the standard deviation, 0.75, and the table kicks out for me right here in a z value, it actually says x equals, of negative 0.67449. Here's what you then do with that. Because in all of these problems, we're using the z-score formula. Z equals x minus mu over sigma. We're told from the table or from the online tool that the z-score, oh, wait a second. I chose the wrong one, didn't I? I started working through this and immediately I recognized I did something wrong because this should not be negative. It should not be negative because I'm not left of the mean. So while this might be the number that my computer spits out, I need to be smarter than my computer to recognize I need this to be a positive value. So that's positive because the z-score I want is to the right of the mean because my x is to the right of the mean because I want the 75th percentile. There's my z equals x minus 5.3 over 2.1. And now we algebraize that thing for it to give me the x value. But professor, I can just put in the mean and the standard deviation with the online tool and it kicks it out to me. You are right, so you immediately have an ability to check your algebra. But this is what I want to see. Why? Because this is very important. Having a picture to represent what's going on is very important, and understanding how that relates to the words is very important. A use or misuse of a technology application, not that important. There are tools out there. We know this. Statisticians know this. Tons of tools. Like mind-bogglingly too many tools. But our job, as we learn this, is figuring out what's the right tool. Am I using the right tool? Do I know the backbone behind what's going on with that tool so I can interpret my results effectively? So, with that being said, let's see, 12 minutes. We will work together. What do you say? Sounds good. IQ is normally distributed with a mean of 100 and a standard deviation of 15. Suppose one individual is randomly chosen. Let X be the IQ of an individual. How would I fill this in? Think, but don't say it out loud. But we will fill this in with this blank, and then this blank, and then that blank. So at this point, and I normally don't do the just shout it out method, but for sake of today, go ahead. What goes in that first blank? Capital N, yes. What goes in the second blank? 100. What goes in the third blank? 15. Okay. It means X approximates a normal distribution with the mean of 100 and a standard deviation of 15. That nomenclature, that way of saying things, talk to any statistician. You write that down, they're going to know what you're talking about. If they don't, I would question whether or not they went to school. All right. Find the probability that a person has an IQ greater than 120. What do I need to start with? That's right, a picture. So for the first one, I have a picture centered at 100. 1, 2, 3, 1, 2, 3. This is 85, just to give perspective, because we said the standard deviation is 15. 120 will be somewhere right about here, because this is 115, and I want to find the probability that someone has an IQ greater than 120. Probability that X is greater than 120. Does it matter if I say greater than or equal to? No, it doesn't matter. It's the same value. Z equals x minus mu over sigma. I write it every time without numbers in it. The reason why is pretty soon we're going to learn a new distribution. It'll have the same format, but instead of x and mu, it'll be x bar and x bar, or mu sub x bar. And instead of sigma, it'll be sigma over root n. So we're going to be using this with other ways. And then we're going to use t. T equals x bar minus mu sub x bar over s over root n. And that'll be another one. So we write the formula first, then we plug in numbers. 120 minus 110 over 15. And someone's doing that in their calculator here in class because I'm not. 5 over 15, 1/3, 0.33 repeating. I guess I could have done that. 1.33, sorry. Yep. It's not 110, it's 100. Don't trust what I write. Listen to what I'm thinking. You can't do that, I know. Listen to what I'm thinking. You all have had parents, I'm sure. Don't do what I said, do what I meant, right? And then we go to either an online tool or something along those lines. And if I do an x value of 1.33 in a standard normal curve, it gives me an area of, I'm going to put that right there, 0.09175. And then I would interpret my results. There's about a 9% chance, or 9.175% chance, that an individual will have an IQ over 120. Although not part of this question, you could say they are clearly in the top 10%. Because they're more, there's 10%, there's more than 90% below them. Mensa. Mensa is an organization whose members have the top 2% of all IQs. Find the minimum IQ needed to qualify for the Mensa organization. Draw a picture. 100. And then I got to try to figure out, what do I do with that? I'm looking for this time an x value, an unknown value. What am I given? I am told this area is 0.02, the top 2%. Top 2%. What do I do with that? If I'm using a table from the books, I'm looking up for 2% in a tail area to tell me what that z-score is. If I'm not using a table, I am using my online tool, and I put in 0 for mu, 1 for sigma. I change my area to 0.02. And it tells me that that corresponding z-score for 0.02 is 2.05375. Come on. Move that up. Z equals x minus mu over sigma. 2.05375 equals x, my unknown value, minus the mean divided by sigma. Algebra that thing to find your corresponding x value. I'm not going to do that right now, but you can finish that pretty quickly to verify that you get that number. After you do that, go back to your online tool or your graphing calculator or whatever technology you're using to find it, and that will give you and tell you whether or not you found the right number. Now, if you found a number below 100, you know you did something wrong. All right? And we know it's top 2%, so we know it probably should be fairly well above the 95th percentile. So in the online tool, this is what I used. So I went to that online tool that we have for all of our applets. I put in 0 and 1 for the standard deviation, 0 for the mean, 1 for the standard deviation. I put in 0.02 here, and it kicks out this as my x score. Well, because I know this is 0 and 1, that's a standard normal curve. That's z. And I use that to find this z-score here. And you can see it matches with my picture. and then go here. Now, if I wanted to, I could go back in, put 100 here, 15 for there, 02, and it will kick out the correct x value. So you wouldn't even have to do algebra. You can do that after you've done all of this. And then last thing is the middle 50% of IQs. I'm going to go ahead and put Z here for now, 0. There's my middle 50%. It's going to be inside of one standard deviation. I know this because one standard deviation is 68%. Now, if I was paying attention on the other one, when I did 75%, I recall that this Z-score here is negative 0.67. This one will be positive 0.67. Or you go back to that online tool, 0 and 1 for the mean and standard deviation, put an area of 0.25 in, because this is 25%. This is 25%. And you can find the Z-scores, and then from that find the two corresponding X values using the Z-score formula. Z equals X minus mu over sigma. Negative 0.67 equals X minus 100 over 15. Solve that one. Then redo it for X equals positive 0.67. Solve it out. You would get then the two corresponding IQ scores for IQs. Yeah, the middle 50%. There we go. That's what the question was asking. Where we're going to come back to when we come back to class on Monday is this. What would happen? So we did this the other day in class where you all did samples of size 3. Okay, we're going to look and see what happens if we use samples of size 5. So from that document, one of the things I need you to do before you come to class on Monday is from that document, that spreadsheet of all the values, please, please, please use a random number generator. Do not be like, I'll just pick 5. I can be random. You cannot be random. None of you has the physiological condition that allows you to be random. Your brains all fire with purpose and in patterns. So use a random number generator as a select. I think there's like 69 or 70 data points, but select 5 randomly, find the average. We're going to enter it on my computer as you come into class on Monday. And instead of 3 times, just because we have about 50 people in class, it'd be nice if we had about 150 data points. So if everybody could, more than 150. So if you can do maybe up to 5 times, at least 3, preferably do it 5 different times. Just bring in 5 then averages. That will also account for the people who aren't doing this, aren't watching the videos, aren't paying attention, and aren't doing the work for the class to compensate for their lack of work. So if you can do it 5 times, that would be even better, and you'll bring that back to class, and we'll look at the results when we get here on Monday.